Welcome to week 14. Prior to class, every week you're asked to review the vocabulary in Quizlet. I will add to that weekly formulas and vocabulary so that your job is to review that prior to class so that we're familiar with the terms that we're using. You can also use that to take notes, and it has formulas there that you can use to solve problems. Also, in the email that I sent and in the course announcements that you're supposed to be checking each Monday, you were asked to watch a few videos. So we want to know, what is the number e? And what do you know about natural logarithms? Before I continue, I have a couple of announcements. I want to make sure that you understand that December the 13th is the end of the semester lock date. All graded work will lock on December 13th at 11:59 p.m. I cannot change that lock date. You will not be able to turn anything in after that date. But also, I need you to be aware that December 2nd is the last date that you can turn in teacher graded assignments. Teachers will be out for state testing during the week of December 5th through December 9th, and you need to give your teachers enough time to grade the teacher graded assignments. So write those two dates down. December 2nd for turning in teacher graded assignments, and December 13 for turning in or completing any computer graded work. Are you caught up? Reach out for support as soon as possible this week. Check your email, the link in the course, or in the announcements to sign up for small groups on Friday. All right, as we started class, we ask for you to chat about what a natural logarithm is. What did you get out of watching those videos? And if you're watching the recording, you can click on those links and watch those short videos and then come back in, take notes, and then join in the discussion. I would suggest that you download the PowerPoint because it will have all of the notes with all of the links there for you. Everybody needs, even if you're watching the video, go to menti.com and use the code 24642284. Or you can scan the QR code and then add to the conversation that we have going on there. We're creating a word cloud, and everybody needs to contribute. This week, we're going to be finishing up Unit 4. Our last lesson is 4.08. So go through that slowly, carefully, take notes, practice. Don't just try to complete your assignments. You need to get into the course daily. Now, today is going to take a little bit longer, so you may not be finished taking your notes, and that's okay. You still need to take your first attempt by midnight on Monday the 14th. So if you're behind, get that done. Whether you feel like you're ready or not, get that first attempt done so that I can help you. Attend Help Lab on Tuesday or Wednesday. Once you come to Help Lab, ask your questions. You can try your second and third attempt. I also have office hours on Thursday at 10 o'clock. So continue working on catching up on missing work, and you can begin to review for the Unit 4 exam. I don't have the review ready yet. Probably won't have that done until over Thanksgiving. So you don't have to start. Use this week. I'm not giving you a lot to do, but use this week to get caught up on everything and come in to ask for help if you do need help. This is our last unit. In this unit test, both parts are going to contribute to a big part of your grade for this semester. Don't forget the ICANN has a lot of helpful material. So if you don't know where that is, and that's if you've been ignoring that all semester and it has no meaning to you, please get that clarified because that could help you a lot. For today, I'm going to be solving, this is you're going to be solving exponential and logarithmic equations so that I can solve real-world problems involving logarithms. And I'll know I have it if I can complete the exit ticket and participate in the lessons. Don't be afraid to try. Trying is part of learning. So our objective is to analyze the key features of exponential and log functions, including domain, range, symmetry, and asymptotes, so that we can solve real-world problems. Let's start off by reviewing logarithmic equations. Recall the one-to-one property of exponents. If we have the same base b, let me get my pen ready here. If we have the same base b, then we can set up an equation where these exponents are equal. So we can set up the equation x equals y. Let me show you where it may be a little more clear. If we replace the base b with the number 2, and we say 2 to the second power is equal to 2 to the x, can you see that x has to be 2 in order for those two sides of the equation to be equal? 2 squared has to equal to 2 squared, so x has to equal to 2. That's what we're saying here. Same base, we can set up the exponents as being equal. The one-to-one property of logarithms states that log base b of x equals log base b of y. I'm just repeating what we said earlier. We can set up the equation x equals y. We can rewrite this and get back what we saw previously. Because we have the same base, the exponents are equal, as we saw in the exponential form. In log form, we can say that this statement here is equal to this statement here. We know that this is not the exponent, but it works the same way. All right, we're going to work out an example. Let me change my pen color. I've got a black background, so let me change it to white. All right, so let's try this example. Log base b of 2x is equal to log base b of x plus 7. And we'll use that property because we have the same log base b. We're going to toss that out. Let's just go ahead and scratch through that. So we're left with 2x is equal to x plus 7. Subtract x from both sides to solve the equation. X is equal to 7. That's using the property, the one-to-one property of logarithms. All right, let's try this example. If you want to pause the video and try it on your own and come back and compare answers, feel free. All right, so we have the same log. We're going to scratch through that, and we're left with the equation x plus 2 equals x squared plus 4x minus 2. Okay, so this is all we have left here. All right, I'm going to subtract x from both sides and subtract 2 from both sides, so I'll get 0 over here. So I'm going to line this up with the x and subtract 2. So I'm left with x squared plus 4x minus x is 3x. And then negative 2 plus a negative 2 is negative 4. Now we have a trinomial that we can factor. You can go into the ICANN and use the factoring calculator that I have right up at the top, or you can use a T-chart for this one. It's very easy to find the factors of negative 4 that multiply to give us a negative 4 and add to give us a positive 3. So that would be positive 4 times negative 1, multiply to give me a negative 4. But when you add these together, you get a positive 3. So we can factor this into x plus 4 times x minus 1 equals 0. Set each factor equal to 0. So we have two solutions here, x equals negative 4 or x equals positive 1. Now you may stop here and assume that there are two solutions to the equation. So let me talk this through. My pen wants to do its own thing, so be patient here. I'm trying to circle this and not confuse you. All right, so those are our two possible solutions. So let me talk you through this. Now, when we substitute that back in, I don't want to make this hard for you because logarithms is a new notation. But think about it this way. We're going to throw out any negative numbers because we cannot take the square root of a negative number. So our only solution that's not going to be imaginary is x equals to 1. I just repeated this, so if you're downloading the notes, you have all of my work shown here. Remember, we have to throw away x equals negative 4 because it's an extraneous solution. We don't want to stop when we get an answer. We always want to check our answers. All right, we have another one to practice with. So if you want to stop the video and come back and compare your answer, feel free. All right, we have the same, let me change my pen color. We have the same base, or we have the same log base 3. So we can toss that out and solve the equation x minus 1 equals x squared minus x minus 9. So we're going to work this the way that we did the previous problem. We're going to subtract x and add 1. So on this side, and I'll go ahead and flip these, this side we have 0. X minus x is 0, and negative 1 plus 1 is 0. So we're going to subtract x on this side and add 1 just like we did on the left. And I'm going to move that over to the left-hand side. So we have x squared minus 2x minus 8. Negative 9 plus positive 1 is negative 8. And again, I can quickly factor negative 8 into two numbers that multiply to give me negative 8 and add to give me negative 2. So that's negative 4 times positive 2. So if we set up those binomial factors, you have x minus 4 times x plus 2 equals 0. And set each of those factors equal to 0, and you would get x equals 4 and x equals negative 2. Now remember, we have to toss out the negative solutions because those will not give us a real answer. So our only solution is C, x equals 4. Again, I've shown my work here, just repeating it so you'll have it in your notes. All right, another practice problem. All right, now we have another property that we're going to introduce here. We have log base 2. Let's check to make sure that these are the same, and they are. Now we have the addition property. Just like when you have an exponent, let's say we have 2 to the third power times 2 to the second power, that would be 2 to the, add the exponents. Okay, so what we're saying here, think of it in reverse. We're adding the logs. We can multiply what we have left here since we have the same base. So this is I'm going to pull this down and take out the log base 2. And I'm going to write x times 2x plus 3. equals 1. Actually, let me start that over again. Let me erase here. This takes some practice. All right, for this one, I want you to notice that we're adding two terms together, but those two terms have the same log base 2. Now, like exponents, let's say I have 2 to the third power times 2 to the second power. When you're multiplying with the same base, you add the exponent. So this would be 2 to the 3 plus 2, or 2 to the fifth power. Now, when we move to logarithmic notation, that's where this translates. So we're adding with the same log, so we can multiply what we have here, these expressions. So we can combine this or rewrite this as log base 2 x times 2x plus 3 equals 1. Knowing what we know about logarithms, we're going to start with the base. So we can rewrite this as 2 to the first power is equal to, go back over here and get all of this, x times 2x plus 3. All right, let's go ahead and distribute this, and we get 2 to the first power, move back over here before I lose you, is just 2. Let's just write that, and then go ahead and distribute. X times 2x is 2x squared, and then x times 3 is 3x. Now I'm going to subtract the 2 from both sides. So I have a trinomial here that I can factor. And over on the left-hand side, we have 0. So go ahead and factor this, put it into your factoring calculator, or use whatever method you want, but factor it quickly. Don't get stuck on the factoring. So that's why I'm saying go ahead and use your calculator. And we get x plus 2 times 2x minus 1 equals 0. I flip the sides around again. All right, set each of these equal to 0 and solve for x. And for this first one, you'll get x equals negative 2. And for this one, you'll have to add 1 to both sides and then divide by 2, so you'll get x equals 1/2. Using what we learned before, we've got to toss this out. It's extraneous because we cannot take the square root of a negative number and get a negative answer. All right, so our answer is C. Showing all the work here again and your notes. All right, now here's the solution for your notes. Step 1, use the product property of logarithms. So I'm giving you the property name so you can refer to it if you're taking good notes or if you're using our Quizlet study set. And then we apply the distributive property of arithmetic so that we have this, step number 3, this equation. I'm showing you all the steps working through what we just did previously. And then we got this, and we moved that 2 over to the right side and then flip sides. We factored it, and then we got x equals 1/2 and x equals negative 2. We have to throw away our negative solutions there because we cannot have a negative, we have an extraneous solution here. So x equals 1/2 is the only true solution. All right, another practice problem. So now let's take a look at this and decide what we're doing here and what we need, where we need to go. All right, so we have log base 3 of the expression x minus 6. That's our statement that's on that line next to log base 3. Is equal to 3 minus log 3x. So what in the world do we do with that? Take a minute, pause the video, and look at your notes, and we'll come back and work this together. All right, so we have log base 3 x minus 6